Hello. In this video tutorial, we will be working on skills practice 15.3, calculating electric fields and forces. Please remember to pause or rewind the video as necessary. Let's begin. Please read along with me. Electric field strength can be described in two ways. Sometimes scientists describe electric field strength in newtons per coulomb of charge. However, in many situations, the unit volts per meter is used. The two units are equivalent. Later, you will be given an opportunity to figure out why this is true. The force on a charge in an electric field is equal to the charge in the coulombs multiplied by the electric field strength. This equation is written as electric force F is equal to charge Q times electric field E. Let's break down this equation. Force is F, and we're given force if we're given newtons. Charge, Q, and we're given charge if we're given coulombs. And finally, electric field strength, E. Now, we know we're going to be given electric field strength if we're given newtons per coulomb. Okay, that is how we are going to tell the difference between them. So again, just to recap, if I am given newtons, I will assign the variable F for force. If I'm given coulombs, I will assign the variable Q for charge. And if I'm given newtons per coulomb, I will assign the variable E, which is electric field strength. Let's go ahead and begin. In the first two examples, we're just going to see how we would annotate these questions so that we can organize our information. In example 1, it says the electric field strength in a region is 2,200 newtons per coulomb. So if I see this, I know I need to annotate that number as E, my electric field strength. It says, what is the force? So F would be the question mark, with a charge of 0.004 coulombs. That would be my charge Q. You can see by plugging into this equation, 0.004 times 2,200, we get 8.8 newtons. I'm not so concerned with the calculation just yet, rather with the annotation of the information to begin with. Let's annotate question example number 2. If an object with a charge of 0.00080 coulombs, so that would be Q, experiences an electric force of 7 newtons, what is the electric field strength? So we are looking for E. You would take this equation, you would solve it for E by dividing by Q. So 7 newtons divided by 0.08 coulombs gives us 88 newtons per coulomb. So that's how we annotate problems like this. Let's go ahead and take a look at 6 actual examples. Again, please remember to pause or rewind the video as you need to. Also, please remember to have your calculator handy and independently put these values in your calculator yourself so you know you can do this yourself. Number 1, what is the force of an electric field of strength 4 newtons per coulomb on a charge of 0.5 coulombs? So I would label it like that. I'm looking for F. I'm given charge, half a coulomb. I'm given electric field strength, 4 newtons per coulomb. The equation I'm using is F equals Q times E. Since it is already solved for force, I can just directly plug in. Charge is half a coulomb. The electric field strength is 4 newtons per coulomb. And you can see when I write it like this, the unit of coulomb cancels and the unit of newton is what is left over, in which we get a half times 4 would be 2 newtons of electric force. Number 2. An electric field has a strength of 2 newtons per coulomb. That would be E. What force does it exert on a charge of 0.004 coulombs? So again, F is the question mark. Again, we are given Q, the charge of 0.004 coulombs. E would be 2 newtons per coulomb. The equation we're using is force equals Q times E. Go ahead and direct substitute into that already, since it's already isolated for F. And it's 0.004 coulombs times 2 newtons per coulomb. Notice that cancels. And if we double 0.004, we get 0.008 newtons. Number 3. A charge of 0.01 newtons is in a 120 newton per coulomb electric field. What is the force on the charge? So here's our charge. Here's our electric field strength. And again, we're looking for force. Charge is 0.01 coulombs. The electric field strength is 120 newtons per coulomb. The equation we're using is charge times the field strength equals the force, which would be 0.01 coulombs times 120 newtons per coulomb. And 120 times 0.01 is 1.2 newtons of electric force. Number 4, an object with a charge of 0.08 coulombs experiences an electric force of 5 newtons. What is the electric field strength? This time we're looking for E. You're given a charge of 0.08 coulombs. You're given a force of 5 newtons. You're going to start with the main equation, F equals Q times E. However, you need to remember to isolate this equation for E. So F equals Q times E. How do we isolate for E? We have to divide by Q. E would therefore be the force divided by the charge, and the electric field strength would be the 5 newtons of force divided by the 0.08 coulombs of charge. So 5 divided by 0.08 would be 62.5 newtons per coulomb. Number 5. An object with a charge of 4 times 10 to the negative 9 coulombs experiences a force of 20 times 10 to the negative 9 newtons. What is the electric field strength in newtons per coulomb? So again, we're looking for electric field strength. We're given a charge of 4 times 10 to the negative 9 coulombs. We're given a force of 20 times 10 to the negative 9 newtons. F equals QE is our equation. And again, you're solving for E. So F equals QE gets rewritten as E equals F divided by Q because we divide both sides of the equation by Q. Plug in, and it's 20 times 10 to the negative 9 newtons divided by 4 times 10 to the negative 9 coulombs. You guys might notice there is a common 10 to the negative 9 right here, and right here. And so those two common points are going to end up canceling, leaving you with 20 divided by 4, which would be 5 newtons per coulomb. And finally, number 6, it says a charge of 0.2 coulombs experiences an electric force of 5 newtons. What is the strength of the electric field? Again, we're looking for E. Charge is 0.2 coulombs. Force is 5 newtons. Electric field strength is what we're looking for. So Q times E equals F. Again, ladies and gentlemen, you're solving for Q. Solving for E, rather. So F would be equal to Q times E. Isolating E, we divide both sides by Q. And it would be 5 newtons of force divided by 0.2 coulombs of charge. So 5 divided by 0.2 is actually 25 newtons per coulomb. I hope you found this tutorial helpful. Again, please go back and rewind as needed.